Why do Python database transactions fail and how to fix? Imagine you're trying to save some important data into a database using Python, but suddenly your program stops working or gives an error. That can be frustrating, right? Understanding why these transactions fail can save you a lot of headaches. When you connect Python to a database, you want your data to stay consistent and safe. But sometimes, things go wrong. Let's look at what causes these failures and how you can fix them. One common reason is logical errors in the code. If your SQL statements are wrong or you try to insert duplicate data that violates the database rules, the transaction will fail. For example, trying to add a record with a primary key that already exists will cause an error. These mistakes happen often if the code isn't carefully checked. Another reason is system errors or resource issues. If the database server crashes, runs out of memory, or if there's a deadlock where two transactions wait for each other to finish, your transaction can fail. Network interruptions between your Python program and the database can also cause problems, especially if the connection drops during a transaction. Sometimes, the way your database driver handles transactions can cause failures. Some drivers automatically commit changes after certain commands, like data definition language commands such as creating or altering tables. This can break your transaction flow if you're expecting to control when data is saved or rolled back. Poor transaction management in your Python code is another culprit. If you forget to explicitly tell the database when to commit changes or roll back if something goes wrong, your data might end up in an inconsistent state. Not handling exceptions properly can also cause silent failures, leaving your database in a bad shape. To fix these issues, always control transactions explicitly. Use commands like commit to save changes and rollback, to undo them if an error occurs. Wrap your database operations inside try except blocks to catch specific errors like integrity violations or operational errors. This way, you can roll back the transaction and keep your data safe. Properly manage your database connections too. Use context managers or finally blocks to ensure connections close properly even if an error happens. Avoid mixing data definition language commands with data manipulation language commands in the same transaction because some databases automatically commit DDL commands, which can interfere with your transaction logic. Using savepoints can help when you're doing complex transactions. Savepoints let you roll back only parts of a transaction instead of everything, giving you more control. Also, check how your database driver handles auto-commit. Some enable it by default, which can cause your transactions to commit unexpectedly. Adjust this setting to match your needs. Here is a simple example in Python that shows how to handle transactions carefully. Import SQLite 3. Def execute query. DB path query params is equal to. Con is equal to none. Try. Con is equal to SQLite 3. Connect DB path. Cursor is equal to con cursor. Cursor execute query params. If not query strip, upper starts with select. Con commit. Return cursor fetch all. Accept SQLite 3 integrity error as E. Print F integrity error, E. If con rollback. Accept SQLite 3 operational error as E. Print F operational error, E. If con rollback. Accept as E. Print F database error, E. If con rollback. Finally, if con close. Return none. This example shows how to explicitly control transactions, handle specific errors, and always close the connection properly. Remember, transaction failures happen mainly because of logical mistakes, system issues, implicit commits, or poor transaction control. By writing Python code that manages transactions clearly, handles errors carefully, and understands how your database driver works, you can keep your database operations smooth and reliable.